Welcome to simulations. A few years ago, I attended a meeting where industry representatives said they wanted students to learn simulations. That's why you will have completed, depending on which course you will have taken, anywhere from 2 per course for a total of 4 or 5 simulations for another program. They wanted students to do simulations. Well, what I also thought would be interesting was learning how to create a simulation from a very basic point of view. So you get just the general idea of how a simulation is created. So this is very common these days. Simulations and modeling is done over and over again. If anybody is a sports fan, they'll at this time, I was reading the other day where they ran simulation of the NFL season 20,000 times to do predictions on like individual games and what records the teams would have. So it's very common. We'll talk a little bit about the Monte Carlo simulation, queuing problems, inventory problems, and we're going to use our Excel spreadsheet to create a simulation, which you will also have in your final exam. So you're trying to imitate real world situations. And with the pandemic, this is what they're doing. They're doing simulations. And they're trying to get a range of and determine it's going to overwhelm the healthcare system. Worst case scenario, best case scenario, and sort of more realistic. So they're going to come up with a probability distribution and see, oh, we need more respirators. Oh, no, we're fine, even if things get a lot worse. So you need to go through the steps, defining the problem, introducing the variables, constructing the model, etc. Running the experiment. I'll let you read the rest at your leisure. But you're not going to be responsible for doing this. We're going to already have the simulation set up. We're going to do a couple of them. The main one I'm going to show you is about running a newspaper stand, and it actually ties in with the very first topic you may have taken in this course, which is forecasting, depending on which course you're in. So here's just, again, a graph on it, finding the problem, all the way to examining the results and selecting the best course of action. So it can be fairly straightforward. It's very flexible. You can change the variables and run it over and over again. Most university programs will at some point have you run a simulation for running a business in supply chain. We had small ones in this particular course, which I think are kind of useful. They're not intended to be a big, complex simulation. They're just intended to be small, introduce you to the concepts and ideas, and get you practice at doing sims. So you can sit at job interviews and say, yes, I've done a simulation. You can see that they're time compressed. Some of the simulations would have taken 2 years of real time, and you can do them in 20 minutes, 40 minutes, whatever it took you. You can run what if scenarios. You run it separately so it doesn't interfere with your real world systems. You don't have to do mock trials. You can run it on the computer. Car companies have done this for a number of years now because it greatly reduced the costs of developing a car. And although that is a bit different, it's still the same kind of idea. You can just do it separately. And you have a lot more control over the variables. It can be very expensive and it takes a long time to set up. You may, depending on how good you set up the model, you may get some fairly poor results. And you may miss things and forget certain variables or not get the weightings correct. So we're going to do an inventory sim that I'm going to show you. We're going to do it based on, and we're also going to tie it in with forecasting. So you want to make sure that you have enough, in this case, newspapers. So I'll go through this in more detail when I show you an example from the book. But in this particular case, you have a reorder point of 5, and you're going to order 5 units. And so the reorder point is 5. The quantity order is 10. Right? So in this particular case, at the end of day 1, you had 10 units. You have a random number of 6, which turns into a demand of 1. So the 10 minus the 1 is 9. Do you need to reorder, or did you have lost sales? No. Day number 2, you have 9 to begin. Random number of 63 is 3 sold. So you have ending inventory of 6. So the 9 minus the 3 is 6. Are you at the reorder point? No. Day number 3, you start the day with 6, random number of 57, which is demand of 3. You have 3 left. Do you need to order? Yes. You have a random number of 2, all right, and a lead time of 1, because the lead time will vary. Day number 4, all right, day number 4 arrives, because remember, there's a lead time of 1. So day number 4, you need 3 units. There's a demand of 5, because the random number is 94. And so you have 2 lost sales. People wanted to buy 5 units, you only had 3. Then, in day number 5, the 10 units that you ordered at the end of day 3, and you receive at the beginning of day 5, so now you've got 10 units. And then you go through the process the same. 3 are demanded, you have 7 left, etc., etc. So you also have randomness for the demand, and you also have randomness for the lead time, because lead time is variable. So then you're going to see whether you order, and every time you place an order, you're going to order 10 units. And once you get down to 5 units, you will place an order. So if you're at 6 and above ending inventory, then you don't place an order. If you're at 5 or below, you do order, and you order them in blocks or lots of 10. And I'll show you how to do this in one of the examples from the book, but that's just a brief introduction to it. And I'll also show you, like I said, the newspaper stand one. So in this particular case, you find the average inventory, take the total number of units divided by the number of days. You have 2 sales lost in 10 days, so an average of 0.2 of a unit. Average number of orders placed, you place 3 orders in 10 days, so 0.3 of an order per day. You do the costing, you do the holding costs, if there are any, the stock out costs, lost sales. You've heard me talk in the course that companies more and more recognize the lost sales. Accountants do not calculate this. So they don't think that there is such a thing, because they think it can't be measured and it can be estimated. So I'm going to disagree with my accounting colleagues. In fact, as a little side comment, I've actually had fairly heated discussions with accounting faculty who actually tell me you can't measure lost sales. That is wrong. I will say that as long as I teach these courses. You can estimate it. Companies recognize that. When I take my students on tours, companies tell us that they measure lost sales and they estimate it. It doesn't go into the accounting records, so industry says it exists. So you take the daily inventory cost, you add the daily ordering cost, plus the holding cost, plus the stock out, and you come up with $6.65. And that's the end of the simulations. Thank you for listening.